1 upon t minus 2 on this equation, and x equal to 1 upon t minus 2. Okay, so we have to substitute in this under the square root in place of x, the same value. This is minus sign. I'm doing this right here. Okay, this is minus dt upon t square upon, this is 1 upon t under the square root. This is x square, that means 1 upon t minus 2 whole square with 4 into 1 upon t minus 2 plus 3. Minus sign, this is minus dt upon t square. We divide by also 1 upon t is t, 1 t cancel out. Let me write here only t. So that will give us under the square root, under the square root. Let me solve it. With 1 minus 2t, 1 minus 2t whole square, okay, plus 4, and if I multiply this by t square, or let me take t square as here, with t here, this will be 2t square, or minus 4t square, okay. If I multiply this by 4, will be 4t, okay, and minus 8t square plus 3t square on, or this 3t square will be there, okay, and the t, and out of this will be t. The square root is cancelled out, so this t and this t cancel out. Finally, what do we get? The minus dt divided by this whole value. Let me open this whole square. It will be 1 plus 4t square minus 4t plus 4t is 4t plus 4t minus 4t cancel out, minus 8t square plus 3t square. Okay, so this is 4t square, 3t square, again minus t square. It will be minus sign dt upon under root 1 minus t square only, because minus 8t square is 3t square plus 4t square, 7t square, so it will be minus t square only. This is sine inverse. It will be minus sine inverse only. Hyperbolic, but sine inverse t only. Why? Because t upon 1 is t. This is sine inverse t. So let me substitute these two values here. And t value is, what is the value of t? T equal to 1 upon x plus 2. We can write it as minus sine inverse 1 upon x plus 2. 1 upon x plus 2 here. Okay. This is value of I2. Finally, let me substitute these two values here. We will get the answer minus sine plus sine. The final answer is cos hyperbolic inverse x plus 2 plus sine inverse what is this? 1 upon x plus 2 plus constant of integration. This is the final answer. Question number second, by rationalizing its numerator. Okay, we have obtained this. Now let me take next question. Question number now third one. Let me check what question number third says. What question number third says here. Let me check that. Now question number third. Okay, the sign of integration is it, let me write 1 plus x upon under root 1 minus x, because both are under this root. What we have to do here? Here we have to rationalize the numerator. In this case, whenever there is a square root in numerator and denominator both, or I mean radical sign in numerator, we rationalize the numerator only. So rationalizing the numerator. So rationalizing, this is rationalizing the numerator by multiplying numerator and the denominator by only square root 1 plus x. So we get, what do we get here? It will be, okay, only 1 plus x, right on this side. divided by, this is 1 plus x only, divided by under root, multiplying this will be 1 minus x square. Okay, now I can separate them. For this is under the square root 1 minus x into 1 plus x. What it will be? It will be a minus b, a plus b, a square minus b square, 1 minus x square only. So if I separate them, this is 1 upon under root 1 minus x square dx plus sine x into dx divided by under root 1 minus x. So first is integrated. What is this first integrated? Let me write here I1 and I2, or simply integrate them. Its integration will be sine inverse x only. Sine inverse x. Why? But this is 1 upon under root 1 minus x. Okay, sine inverse x integration. This we know what. Since integration dx upon under root 1 minus x is equal to sine inverse x. So integration, same integration here. Sine inverse x only. Plus sine, if I take, let 1 minus x square equal to t only. What it will be? Minus twice x into dx equal to t. Okay, differentiating it with respect to t, then put all let 1 minus x square equal to t in this question, second part. Okay, so this will be x dx or equal to minus dt upon. Okay, so here we can substitute minus sign 1 upon 2 sine of integration dt upon under root t. Okay, so under root t can be taken as a numerator. It will be sine inverse x minus 1 upon 2 e raised to power minus half sine of integration dt. How it can be integrated? Sine inverse x minus 1 upon 2 t raised to power minus half plus 1. That means plus half only. Divided by plus half. This half cancel out. Okay, so only plus constant of integration. Final value will be sine inverse x, which is minus under root t only. Plus constant, this is square root 2. T raised power half is square root 2. We have written here, sorry, square root t. This case t is there. Okay, so t is what? 1 minus x square. Substitute that. Finally, we have obtained the value sine inverse x minus under root 1 minus x square. This constant, so this is the answer. Okay, so rationalizing numerator in this case, that has given the function which is integrable. To reduce the function integral irrational function. This was irrational function, we have rationalized that, finally we have obtained the answer of this. So this is the process of integrating the irrational functions which are to be integrated by reducing integral functions by rationalizing numerator or denominator. This kind of questions we are discussing about. Okay, now question number 4, let's talk about. Okay, so question number 4 now. Okay, question number 4. Okay, this is also the same type. X plus 1 upon x minus 1. Simply, this is under root x plus 1 under root x minus 1. Okay, similar type again. Rationalizing numerator. Rationalizing the numerator by multiplying again by multiplying numerator and the denominator by under root x plus 1. We get what we get. So not only in the numerator we will have free from radical sign. But if I multiply under root x into under root x plus 1 into under root x plus 1, square root is cancelled out. In the denominator we will have x plus 1, x minus 1, this will be x square minus 1. Okay, so this is dx. Let me separate them. Will x upon under root x square minus 1 plus sine 1 upon x square minus 1 under the square root. This is dx, this is dx. This is I1, this is I2 equal to, sorry, I1 plus I2. Here I1 is equal to, let me do them separately. This is under root x square minus 1 plus. Now in this situation, whenever x comes in the numerator, we have to assume this whole equal to t. So let x square minus 1 equal to p, differentiating it with respect to p, it with respect to t. So we get, what do we get here? Twice x into dx upon dt equal to 1, or 2x dx equal to dt, or x dx equal to dt upon positive value here, that is substitute. This is 1 upon 2 dt upon under root. Again t is taken in the numerator, it will be minus half over into dt, this is minus half over. Now it can be integrated, this is 1 upon t raised to power minus half plus 1 upon minus half plus 1 plus constant 1 upon 2 t raised to power only half, that means square root t upon 1 upon 2, 1 upon 2, and this 2 cancels out. Okay, so this will be only under root t, which is nothing but what is t here, x square minus 1. This is plus constant c is also here written, or let me write this in the end. This is value of I1. What is I2 here? Simple integration. I2 is cos hyperbolic inverse x, that is I2, and I2 is equal to right here, and I2 is equal to sine of integration 1 upon under root x square minus 1 dx. This is nothing but cos hyperbolic inverse x. Okay, therefore final answer is I1 plus I2. What is I1 plus I2? Therefore I1 plus I2 is equal to, what is I1 here? I1 by this one, under root x square minus 1 plus sine is plus sine cos hyperbolic inverse. What half cancelled out here, half by there. No, this was, what was this half? Okay, this half by also cancelled out. This half by also cancelled out. In case of I2, where is I2? Okay, I2 is this directly integrated, so thereby no half, but in this case half is cancelled out. There is no half in both the cases. This is this, and cos hyperbolic inverse x plus constant c. Now this is the answer, final answer. Final answer is this. This is the answer here. Answer of question number 4. And root x square minus 1 plus cos hyperbolic inverse x. That is the question. Answer I mean. Question number 4 is done. Let us talk about question number 5. Now question number 5 is what? Let me talk about question number 5. Now it's black. Okay, question number 5 here. Now this is sine of integration x under root 1 minus x upon under root 1 plus x. Let me write separately. This is this, what we have. Again, rationalizing numerator. Remember, numerator is given under this root. Multiply that by the same value. Okay, so rationalizing is numerator. Rationalizing on, let me write, on rationalization of the numerator we have to multiply the numerator and the denominator by under root 1 minus x. So we get, after multiplying numerator and denominator by under root 1 minus x, what do we get? Multiplying numerator and denominator by the same value as in the numerator. This is numerator rationalization of the numerator. Okay, the same process. It will be x into 1 minus x only, divided by under root 1 minus x square dx. This is what we have obtained here, x upon under root 1 minus x square dx. This is minus sign of x square, okay, upon under root 1 minus x square. Now it can be further resolved, or this is minus sign, if I write here minus sign only, and add 1, subtract 1, no change. Minus 1 and plus 1 cancel out, so it is still minus x square. X into minus x and minus x square. Now it can be divided, it can be separated into two parts. So this is, let us first write this. This is under root 1 minus x square into dx plus sign 1 upon, sorry, yeah, this is 1 minus x square upon under root 1 minus x square, that means under root 1 minus x square y. So this is 1 power, this is half power, 1 power, half power will remain in the numerator into dx. Okay, so this is minus sign, second one, sign of integration 1 upon under root 1 minus x square into dx. There are three parts here, I1, I2, I3 minus I this plus sign. So I1 plus I2 minus I3, let me take them separately here. Okay, so let me write them separately, solve them separately. So first I1, let me take what is integration of I1, how to do I1. So I1 is equal to sign of integration x upon under root 1 minus x square. Let 1 minus x square equal to t. Therefore, differentiating it with respect to t, we get minus twice x into dx on dt equal to 1 to equal to dt. Therefore, x into dx equal to minus dt upon 2. It will be minus 1 upon 2 sign of integration dt divided by under root t. It is nothing but minus half under root t, because here is for minus half plus half is plus, sorry, minus half plus 1, that means plus half. So under root t only divided by 1 on 2. This one on 2. Only minus under root t into that. This is minus under root t means 1 minus x square. This is I1 here. This is first equation. Okay, now I2. So I2 is this. This is simply written as, this answer is, let me write answer. If you 1 upon 2 x under root 1 minus x square plus sign here 1 into, it will be sine inverse quadratic, or maybe written as a square into log of x plus under root 1 minus x square, but we can write sine inverse x. So this is only sine inverse x value of, okay, it's sine inverse x, or it can be written as log of x plus under root 1 minus x square. That is also the answer. Okay, so this is second, first part, second equation. Now let me take I3 here. What is I3? I3 is simply integration. That is sign of integration 1 upon under root 1 minus x square dx, that is sine inverse x. This is sine inverse x only. So half sine inverse x, this is minus sine inverse x, because minus sine inverse x. Now let me substitute these values here for the final answer. This is first one, that means minus 1 minus x square, and then I2 is this is plus sine 1 upon 2x under root 1 minus x square. Okay, then this plus half sine inverse x, and this will be minus sine inverse x. Why? Because I3 is this sine inverse x. It is minus sine inverse x. Okay, plus constant of integration we get it, but these two can be assembled, can be mixed, I mean, can be combined. They are minus, these two values are similar looking, but 1.2x minus 1 is there. We can write here, okay, x minus 2, it can be written x minus 2 upon 2, x minus 2, x positive, and 2 will come here upon 2, under the square root 1 minus x square. Now these two we have combined. What we have done, this 2 will come here minus 2, x minus 2, x minus 2 upon 2, under root 1 minus x square we have taken common, okay, this value, and this is minus half Because this minus 1 and this is plus half. Minus half will remain sine inverse x. Plus constant c. This is the answer here. Last line is the answer. X minus 2 upon 2 and root 1 minus x square, second bracket, minus half sine inverse x plus constant c, constant of integration, c is constant of integration. This is the final answer. Okay, so question number 5th we have done. And let us talk about 6th question. Now question number 6th, what does it say? Okay, question number 6 now. Okay, question number 6. Sine of integration 1 upon, okay, this is x plus under root x square plus 1. Alright, this is dx. Now rationalizing the denominator. What is denominator is to be rationalized now. What is rationalization of denominator? Let you take that. Sorry. Okay, but no, denominator is to be rationalized. So rationalizing is denominator. Rationalizing its denominator by multiplying by the conjugate. Whenever denominator is rationalized, okay, then denominator is rationalized by multiplying its conjugate, by conjugate of it. Multiplying by the conjugate of it. Conjugate of it. What is conjugate of it? That is by x minus under root x square plus 1. If we multiply numerator and denominator by this, what is this? X minus under root x square plus 1. What do we get here? This is x minus under root x square plus 1 divided by, okay, the denominator will have x square because a square minus b square. This is square root is cancelled out. Okay, a square minus b square, a plus b, a minus b multiplying x square minus this square, but this square means square root cancelled out. This value it will be dx. Finally, we obtain under root x square plus 1 divided by this is x square minus x square minus 1 into dx. Only negative value here. This x will cancel out. Minus 1. It will be positive. That means under root x square plus 1 or 1 plus x square. Okay, and this is minus x. Sine of integration dx. Let me separate them. This is integrated as what is under root 1 plus x square. Okay, this is sine hyperbolic inverse type. Simply 1.2. Let me write directly. This is x square plus a square type or a square plus x square type. It will be 1.2 x plus under root x square plus 1. Sorry, x into. I'm writing what x plus x into 1. Sorry. This is x into under root x square plus 1. Okay, plus sine a square is 1 only. This is sine hyperbolic inverse x. Either this or we can write it as log a square into a square is 1 here, only 1. That means log of x plus under root x square, which I was writing here previously, x plus this. Okay, that will be written here, log of x plus under root x square plus 1. Okay, but instead of that we can write sine hyperbolic x plus, or it is minus sine x square on 2 integration plus constant is the final answer. If I separate them, no combination as the answer. So final answer is this. 1.2x into under root x square plus 1 or 1 plus x square 9 plus sine hyperbolic inverse x. This value. So direct integration of this under root x square plus a square plus x. This I have defined a number of times in the previous lectures. Okay, please just remember this formula. The x square plus a square, x square minus a square, and a square minus x square. There are 3 formulas for that, and that they are expressed in either this in place of this log sine hyperbolic inverse x, or sine inverse x, and second was cos half the inverse x. Because if it is x square minus a square, then it will be minus sine, because x square minus a square, it will be minus a square into cos half the inverse x upon a. That will be there. And here it will be same x and then x square plus a, x square minus a square. So those are the three formulae: x square plus a square, x square minus a square, a square minus x square, or x square minus a square, and x square plus a square, three formulae. Also, we have defined already, and this is directly integrated x square upon 2 and plus constant of integration, because they are indefinite integrals, so we write constant. It is required. Okay, sometimes people are not writing them, but we write because it is indefinite integral, not definite integral. In case of definite integral, we never write constant. So that is a unique value. This is not a unique value. So this is question number 6 we have done. Now let me talk about question number 7. So question number 7 now is what? Let me talk about question number 7 here. But we have question number 7 is okay, under root 1 plus x square, right? 1 plus x square divided by only 1 minus x square, right? Dx. Again, in this case, numerator is to be rationalized by multiplying by the same value. Here, numerator is to be rationalized. Here, the numerator is to be rationalized. Is to be rationalized by multiplying numerator and the denominator by under root 1 plus x. It's the same value. So we get, what do we get here? This will be square root cancel out, so only 1 plus x square divided by 1 plus x square divided by 1 minus x square into under root 1 plus x square dx. Okay, so now we have to separate them. How we can separate them? If I take minus sign common from this one, sorry, if I write it as sum of integration minus sign and minus x square, okay, and this is plus 1, that was plus 1 here. So minus x square, no problem, and plus 1 is required. Plus 1 is already there, but it is minus 1 here. Plus 1 was there, only minus sign are taken common. So it will be minus 1, because minus 1, so it will be plus 1. Okay, but plus 1 is required, so plus 1 is already there. Only minus sign we have multiplied by. Okay, so this is because 1 was already there, so this is minus 1 x square, but then it will be 1 minus x square. We have to convert it into 1 minus x square. Minus sign we have taken common, divided by 1 minus x square into under root 1 plus x square into dx. So this, it will be minus sign. Okay, so if I write minus 2 plus 1, then what it will be? It will be minus 1 then. But minus 2 plus 2, we have to write here. Because 1 minus x square, because this 1 plus 1 was already there, but only minus x square we multiplied by it. So, because this is not separated, 1 is not changed then. But while minus sign we have written down, because minus sign we took common, minus 1 was there. Just to remove that, we have to put plus 1 also. Okay, this, sorry, because this was minus 1 here, but plus 1 and minus 1, we have to add on our own. Because minus sign, if I taken multiply by minus sign, add this and taken common minus sign, be this value, but we have to have minus x plus 1. It will be minus 2 here. Okay, that is there. Let me write it as, now this is what? Let me write 1 minus this 1 minus x square. Okay, divided by 1 minus x square under root 1 plus x square into dx. And second sign will be, this is minus 1 minus 2 plus 2. Right, now it is okay. Plus 2, that means 1 upon only this whole value. 1 minus x square under root 1 plus x into dx. This quadratic equation is there, but we substitute here x equal to 1 upon t. Then we substitute. We have to substitute here x equal to 1 upon t in this equation. Okay, so 1 upon t square and 1 upon t, that will be there. So I have to take double, we will write that separately, but this is what we have got, this minus sign 1 upon under root 1 plus x square into dx. Well, this is 2 of integration 1 upon 1 minus x square under root. This is quadratic equation in the denominator, sorry, in the rationalized and independent of rational radical sign. I mean, under the radical sign, quadratic equation, without radical sign, this is quadratic equation. This we have explained in the previous lecture. What we do, we substitute here x equal to 1 upon t. That I'm just going to do. But before that, this is the I1 case. This is I1 and plus 2I2. This is I2. So let me take them. So this answer is simple. What is the answer? This is minus sign hyperbolic inverse x. Why? Because this is under root 1 plus x square. So this is sin hyperbolic inverse x only. Okay, this is done. Plus 2 into I2. Let me solve here I2. What is the I2? Let me take it here. So I2 is equal to sign of integration 1 upon this is value 2 I'll multiply later. This is 1 upon 1 minus x square under root 1 plus x square dx. Putting x equal to 1 upon t. Therefore dx equal to minus dt upon t square. Why? Because dx upon dt equal to minus 1 upon t square multiplied by dt. Differentiating it with respect to t. T raised to power minus 1, differentiate